The purpose of this model is to understand why when incomes rise, fertility falls if people like their kids. This model, this explanation, owes to Gary Becker, and I put on the course site a reference to the paper where this model, this quality quantity model, was originally developed. In economics, we abstract from issues we don't want to explain in order to focus in on better understand the issues we do want to explain. And in this instance, I'm going to abstract away from there being differences in how parents treat their children. I want every child to receive the exact same investment, which we'll call Q. There are N children, and the family's preferences are about maximizing their utility, which is a function of the quality of their children, so the investments that they make in each child, the number of children, and the family's standard of living, S, which is the money that they have left over after they've made decisions on about investments in children. We'll fix labor supply and all that, abstracting from that, so we'll have some endowment I, which is the family's income that they can spend between their standard of living and the production of kids of a given quality. So I will be allocated between the standard of living, pi s being its price, and the spending on child quality, which we'll call pi c is the price, and then the amount of child quality that the family is going to have to buy will depend on how many children they have and the quality per child, so n times q. Notice we can rewrite this budget constraint then as I minus pi s times s is equal to spending on children. Now dividing that by pi c, we get a budget constraint that depends on, the relative cost of standard of living production relative to child consumption. Now I want to draw this in Q and N space. So just rewriting this, we get Q is equal to I divided by pi c minus pi s divided by pi c times s times 1 over n. Now notice, this is our budget constraint, right? But our budget constraint isn't going to be a line in QN space. Okay, it's going to be a curve. And that's one of the things that's funky about this model. Now remember, the slope of our budget line, our budget curve in this instance, is the marginal rate of transformation. It's how I can transform, N into Q in this case. So I can give up a little one good and get more of another good in a more general case. In this instance, so in the usual budget line, the marginal rate of transformation is constant. It's the relative prices, it's the slope. But here, the marginal rate of transformation will depend on what values of N and Q you have. Put another way, given that you're investing the same amount in child quality for each child, then the cost of adding a little extra quality is going to depend on the number of kids, or the cost of adding some additional kids will depend on the quality that you're putting in each of those. So what that means then is that the marginal rate of transformation between quality and quantity will depend on what consumption of Q and N you have. Let's see this a little bit graphically. Now we'll be in shape to draw this curve. Notice it's not going to intersect either axis, so we'll wind up with something that looks like. In that kind of budget curve is different than you're used to dealing with. You're used to seeing budget lines that intersect axes. Here we're going to have a budget curve, And the easy way to get confused is to think about this budget curve as actually being preferences. It's not preferences, it's just the budget. It's the budget curve, and we'll return to the subject of preferences in a little bit. Here I want you to think about what happens now to our budget curve if income, remember income is I, if income increases. Well, what that's going to do is it's going to shift our curve out as such. So we'll wind up then with a new budget curve if income increases. And so that's analogous to what you're used to seeing with a budget line where we shift out the curve if income increases. So there's no real change there on that. What is different here, of course, is that the marginal rate of transformation, aka the slope of your budget curve, is changing with Q and N. And you could imagine drawing in a marginal rate of transformation by just seeing what the slope of the budget curve is at any point. So, down here, our marginal rate of transformation looks something like that. Up here, where there's lots of Q and relatively little N, our marginal rate of transformation looks like that. So you've got a marginal rate of transformation that depends on what Q and N the agent is choosing, and that means then that effectively marginal rates of transformation will change as income changes. So the price of child quantity and quality changes as income changes if preferences are such that you change the ratio of Q to N as you get richer. And the next thing we need to add in order to sort of try to solve this model is to add in preferences. We'll assume that people don't want to have children that have no quality or quality with no children, so that Q and N can't be perfect substitutes for each other. What we'll need is a preferences that are more convex than our budget curve in order to have the highest utility achieved somewhere where there's a combination of Q and N. So for example, we might have preferences that look something like that, and then that tangency of preference of our indifference curve to our budget curve gives us the optimal amount of number of children and the quality invested in each child. Now let's think about the impact of changing income. So remember, with a change in income, our budget curve is going to shift out. Okay, so that is income increases. And now what's our new equilibrium? Well, of course, it'll depend on preferences. And let's say, given our preferences that we have here, that marginal rate of substitution equals marginal rate of transformation is right up there. And so with this increase in income here, we've got an increase in quality and a slight increase in fertility. Quality per child is increased because you see the increase in Q is bigger than the increase in N, but both are rising with income. Now let's look at a framing of this model where income rises and people cut back on the number of kids that they have, despite the fact that they get utility from N, from additional kids. So I've drawn one equilibrium here with an initial budget curve. Now let's add income. Okay, so that shifts our budget curve from BC0 to BC1. And now, given our preferences, now we've got U1, where's marginal rate of substitution equal marginal rate of transformation? Well, given these preferences, we've decided with that increase in income to really up the quality. And in so doing, because of that budget constraint, we've had to drop the quantity. So there's a model. We love our kids. We love our child quality. Our preferences for quality relative to number of kids induces us with a rise in income to invest more in child quality. Now I want to talk about this using the language of income and substitution effects that we've had before. Recall that the way that we separate out income and substitutions effects depends on prices, right? So here, in order to separate out the income and substitution effect, I want to see what's the change that arises because of a change in prices versus what's the change that arises because of a change in income. So in order to do that, I'm going to fixed prices, see what our change is that arises because of the change in income, and then I'll let the price change tell me what that substitution effect is. What are prices? Well, they depend on what your consumption of Q and N is, right? Because the marginal rate of transformation, aka the relative prices, changes based on how much Q and how much N you have. So let's start with our original prices, which we can pick down here as the slope of your budget curve at your initial optimum. Okay? So now let's fix those prices and go up to the new level of utility we had. Well, it looks like at those prices we would wind up here. Okay? So by fixing prices, this movement from point A to point B, that would be the change that's induced by the income effect. And then the move from B to our new equilibrium C is our substitution effect. It's the change that's induced by the shift in relative prices. That leads us to a puzzle, which is why would N, so child quantity, become relatively more expensive as incomes rise? And to put it another way, why would we expect the substitution effect to dominate the income effect as incomes increase? Something we'll talk about in class, something for you to think a little bit about.